Thank you very much. It's really nice to be here. As someone who used to work in the late 70s and early 80s with green bar pieces of paper trying to figure out what patient was in what bid, this is a really interesting transformation for all of us. Recently, up until 8 weeks ago, I was the Chief Data and Analytics Officer for Optum, which is the data and technology side of UnitedHealth Group. And I recently went over to the benefits side, but that's not important. It's all important work that we need to do wherever we are. I'm not going to recopy or reiterate what some of the other speakers have already said. We are here because we've got some challenges that we need to address in healthcare, and we're trying really hard to make this work for everyone. And most of my talk's going to be focused on how do you get it from molecular biology into the hands of clinicians and patients so that they can make the best decisions that they can make together about their healthcare. And these are some of the challenges as we see them and as you probably see them too. First of all, the amount of data, which Colin spoke about very eloquently relative to the explosion of it. There's tons of it, and there's a sea change, a tsunami of data coming at clinicians. I'm a clinician by background. And one might argue that we're still not fully adept at using the data that we have in order to treat patients and meet them where they are. The second one is clinical knowledge growth and change. I mean, in 2008, if I remember the statistic correctly, there were over 18 million biological, biomedical, cataloged pieces of research out there. And this year alone, in 2012, we're going to have 1 million more in 2012 alone. As a clinician, you can think about that in terms of if I were trying to manage the rules on, I'll make it up, on Wall Street, and they change 25 times every single hour, that's the kind of change you're talking about in clinical medicine. And while there's a lot of research going on, the ability to synthesize that, I'm going to use that word a lot as I speak here, so that it actually can improve healthcare in a sustainable way, again, where the patient meets the system or the clinician, is what we're most focused on. Importantly, the federal government and many, many people are changing the way in which the system works, for one, from pay for every widget to pay for the value and the outcome of care. So importantly, making this shift to helping clinicians being able to really utilize this stuff in a real way when a patient's sitting in front of them or a family with a child is sitting in front of them. If we don't affect that change, it's going to be really hard, no matter how much research we have, to be able to really improve healthcare in a sustainable way, don't you think? Thirdly, bringing the right eyes to the data. As someone who's been responsible for a lot of researchers and innovation labs and things in the past, we tend to have the data people, the health economists, the clinical people, right, all kind of, I don't want to say separate. But one of the things that we need to work more on is, as we iterate, which is my fourth point here, bringing the right eyes to the data. And I'm going to show you a tool that we developed in order to do that. And the last thing is, this rapid iteration also refers to not just, my slides aren't up. Oh, am I not advancing my slides? Hello. Hello. Let me just go back one, because I'm not there. There we go. Trying to rapidly iterate to an actionable result is really critical to be able to make this happen. So if you think about healthcare, there's latency built into almost every step of healthcare, right? You take the x-ray and you get the results back 2 days later. You draw the lab work, and unless it's an urgent or emergent situation, you get the results much later. And then everything is a many-to-one relationship. Unlike most data that you'll see, when you get back a lab value, when they draw those 3 tubes of blood on you, a red top, a green top, a purple top, right? You can get back 60 values from that, okay? And the values mean something to your historical information, they mean something to your current symptomatology, and they mean something to each other. So when you start thinking about making those kinds of relationships actionable as the patient sitting across from you, that's the real challenge to me. And we want to talk some more about that as we have this discussion. So this has been our approach, creating a culture of learning and innovating versus telling and knowing. And I think this is happening in medicine too. I think physicians and other clinicians are working with people to help them to understand their care and innovating in the ways in which they might be able to manage their care. Okay? And I have relatives who are diabetic that if there's no grits in their diet, they're never going to follow that diet. It's not going to happen, right? So you've got to meet the patients where they are. We have to increase our experimentation and balance the new with the old. This is what I mean by we've got a lot of data now. We can launch from where we are. And while I can see there's tons of innovative, creative visionaries speaking at this conference, and we need you, please lead us to the right place. I pray for you. I pray for you every day. We also need to make sure that we're using what we have now, okay? And to some degree, there's a lot of discussion between us when we're doing our strategies about culling back on the data. What are the most critical things that we need to have in order to be successful as we move forward right now? And those data elements aren't huge. They really aren't. Tempering our experimentation with scientific rigor, obviously we have to do that. We have to have validity and reproducibility and transparency in our results. But lastly, not confusing technology with data competency. I mean, I have never seen a data problem that we can't throw some technology at. So we can move bad data around faster and prettier than ever, right? That's not what we're trying to do here. And that's why the current traditional view of information delivery is one that we're trying to change the paradigm on in order to truly meet the hearts and minds of patients and clinicians who are treating them. You know, this was the old one: get the data, organize it, enrich it, analyze it, and then deliver it pretty much. But we're changing this paradigm, especially at the analysis point, into one where we synthesize. Because remember what I said about healthcare data. It's not just the presence or absence. It's not a greater than, lesser than equation. It's the patterning and the sequencing. It's more than that. And then how that meets up to the individual genetics of that patient, which I'm so glad that the previous speaker spoke to that. So what we've tried to do with some of our initial forays into the big data world is to say something like this. What if I, as a clinician, could tell that a 36-year-old man that's in front of me is going to be a diabetic in 6 years with an accuracy rate of 72%? What if I knew that? And what if I knew the things that led up to that person becoming a diabetic? And what if I knew that and could inflect the healthcare system to prevent that person from becoming that diabetic? To me, that's the essence of what we want to do, and that's what we've done with one of the tools that we've built. We're using a longitudinal approach to the data in a technology that we call the natural history of disease. We're looking backwards and forwards 17 years over time and carving out subpopulation and choosing people by very different parameters and then tracking them over time and looking at those patterning and sequencings of care. And we can compare this to any other population. And what we call this is the natural history of disease. Now think of this as if you're in the shopping mall and thousands of people have stood at the shopping mall board before you, and thousands of people have left that shopping mall board, okay? So you're at the board looking for JCPenney, okay? What if I could compare how people came to that board before they got to that decision point, and what happened to them after they left that? That's what natural history of disease includes. It's a large data set that includes lots of lab values, lots of what you call administrative data, claims data with all of its limitations, some EMR-based data, which we're just really getting there with that. And we're creating thousands of what we call medical twins for any individual groups of people, and actually looking at that trajectory of care. Importantly, we can run these data on a patient from the time they register at the front of a physician's office to the time they get into the exam room. And we can see thousands of iterations of that and spit out outputs to clinicians in real time that show what the best, most favorable outcomes of that care is in multiple parameters. And this is real now, and we've been able to do that because of the technological advances, but also understanding the underlying algorithms of how that data need to work together. So everybody likes to use diabetes. I'll use diabetes and simplify this a little bit when I talk about our example of being in the shopping mall. If you think about somebody that has metabolic syndrome, pretty much very far before that person is actually viewed to have metabolic syndrome, which everybody knows what that is, right? You get a bigger belly and you have a higher BMI and your blood pressure might be up and your blood sugar might be a little bit off. Pretty much that's metabolic syndrome, okay? But what if you could find the conditions associated with metabolic, and people would call this primary prevention, people might call this just good medicine. But the issues is that more than just obesity and some other very visible symptoms occur. I'm going to show those to you in a second. Actual chemistry changes occur in this, with these patients, whereby if you can find them before they happen, you may very well be able to mitigate the issues around developing diabetes. Now, when we look in our data set, and I'll show you some shots of the tool in a second. I was actually going to do a demo, but it's too risky with all the, internet and everything. It didn't quite work out as well as I would have liked to. But the beautiful thing about this type of viewing of data is, remember, if you're in the health plan business or in the disease management business, you will say to someone who's purchasing a disease management program, we can give you an ROI of X, Y, and Z. But what this technology actually says is if everyone starts off at the same place, and I make an anchor date of the date that you were diagnosed with X, with metabolic syndrome, I can find everyone that led up to it. And after that point, I see three things. I see people that go on to get diabetes. I see people who maintain metabolic syndrome but don't get diabetes, and I see people who get well. And I actually see the real cost differential between them, not the made-up one. You know how you're trying to prove the null, right? That something that didn't happen? So all of a sudden you can actually look at the data by looking longitudinally rather than cross-sectionally at the information over long streams of time and be able to really understand what's working and truly what is not. Now I'm going to very briefly, in the interest of time, go through a few of these screenshots just so you can see some of the things that we're looking at. This is the actual technology, and I was going to stream it on the screen, but we weren't able to. We can slice and dice these data by anything, and it's instantaneous, which is what I had wanted to show you. In this particular screenshot, we can see all the primary criteria of gender and age and insurance and income, and we've added race and ethnicity to these data. We've got patient preference data. We have the Social Security mortality index in these data. So lots of ways to be able to look at the information. We can create a cohort of interest. In this particular instance, this was diabetes, and we can slice this by lab, by anything that you want to look at, by people that are on oral anti-diabetic medications, by people that are on insulin, or in combinations thereof. And we can do it very quickly. And remember when I said to you, it's really important that clinicians be able to see these data. And this is where it starts to get really powerful. The bottom graph is a tree map. Many of you are familiar with this. The darker the red, the more the cohort group, the group that we're studying, has more of. And the lighter, if it's white, it means it's just about even between the study group and the control. And if it's very green, it means that it's much more in the control group's purview of where these data are coming from and where we're seeing these conditions. And what we can actually do is move the timeline, and if I was able to show you the demo, I can actually move that line at the top of the graph, which is in the middle, is the anchor event, move it backwards and actually show over time how those conditions changed. So I can snapshot it, and I can do it over time in a way that helps me as the clinician understand, is the treatment from where that person come and where they are now and where they're going to actually change their treatment trajectory. And like with any good tree map, you can drill into this and see that a hypertensive patient with diabetes is 10% more costly even 6 months before their diagnosis. We can look at what drugs they were on and when. Remember, sequencing and patterning of care matters to healthcare, whereas in a lot of other places they don't. Just the actual result matters. This is very important to us. We can see and isolate these differences over time so that we can actually understand, as I mentioned before, those who don't get the condition, what did we actually do? And lastly, these lab value shifters are just the most incredible thing that I've ever seen. This particular shifter shows a 20% plus change in C-reactive protein in diabetics 6 months before they were diagnosed. Another study that we did, just running the data, shows changes in gastrin. Gastrin is an enzyme that's released in the stomach before you eat, as you start to think about eating. And diabetics have a 26% higher rate of gastrin release 2 years before they're diagnosed. 2 years. So as you can imagine, we're working a lot with biomedical researchers at a lot of big-name universities and medical systems that you would know if I named them. I'm not going to right now, to try to understand better what this means. We're looking at adding genomic data to this, which Colin knows, and doing some very interesting things with that too. But we couldn't do this with our traditional technologies in a traditional insurance environment based on transaction-type data. It wasn't going to work. So we've created an environment our technologists have, and I am not a technologist. I'm a clinician and I love data, but I am no technologist. Whatever they did, if you want to know, come ask me and I'll find somebody for you to talk to allow us to do this in real time, in a real way, with interfaces that make sense to clinicians who are taking care of patients. So We also have a similar tool that we're creating and actually beginning to prototype with consumers that includes preference data, their historical medical history, their own personal preferences about healthcare, and synthesizes it in a way that they can also understand. But what we're doing with this current tool is adding a number of data elements that we talked about, actually looking at creating care pathways. Right now, care pathways are created by ad hoc clinicians sitting around a table and going through the literature and figuring out what it is that they need to do. What if we could find the best care pathway using data, add that ad hoc knowledge, and be able to actually step measure it over time in a real way, not just in a, yes, they followed the protocol way. It would be really cool. And then the last thing we're doing a ton of work with is in the area of pharma research and discovery and comparative effectiveness research. So I went through that really quickly, and I apologize for that. I also have a terrible, wicked Boston accent, and I talk fast, so I apologize. I hope you were able to get most of that. And again, I thank you so much for allowing me to talk today.